Okay, what you are looking at here is the bottom of my coffee table. So this side would be the front of the coffee table where you sit at the sofa. And this would be the underneath of the coffee table. What I have here is I have a 3-step one direction and 3-step to the other direction. So I wired this so the speed will go on the first click to the left or the right will give me a slow speed, a medium speed, and then a fast speed. And then when I put it back in the middle, it's off. Okay, so if I need to get to the battery, I just need to undo these 4 screws. Okay, and inside you see I have a 9.6 volt, 2400 milliamp AA battery pack. Now connected to the positive side, I have a fuse. I always fuse all my projects just to be extra safe. If anybody would short out the rails, nothing's gonna happen, it'll blow the fuse. And I temporarily had a 2 amp fuse in there, so I'm gonna put a 1 amp fuse. I think that's more appropriate for this. Never gonna see anything more than 1 amp. Okay, so as you can see here, here is the circuitry. Here is my 7-position switch. The center tap I'm using as off, so nothing is connected to that. 3 positions to the right and 3 positions to the left will determine the speed and the direction. So if I turn it one direction, the first step will give me a low speed, second step will give me a medium speed, and the third step will give me a faster speed. And that's all determined by these resistors that I put in series. Now the direction is controlled by this relay. So I had to be able to sense, this relay had to sense which direction I was turning in. So when I turn it in one direction, it actually powers this relay to turn on. And simply that is just like a double pole, double throw switch. And that will make the train go in one direction. When I turn it the other direction, the relay shuts off and the train will go in the other direction. And right here we have a charging port. So the nice thing is when this is in the off position, there is no connection between the battery and the circuitry. So I can plug in my plug into here, which will charge through this fuse and charge this nickel metal hydride battery. So just let me reassemble this and okay, so I'm going to give a quick explanation of the circuit. Inside this yellow box right here, what I have is a rotary switch. So this arrow will point to the different points in the switch. Okay, and this is a double level switch. So it's a double pole 7-throw switch. So it'll throw to 7 different points along the rotary switch. The middle point is off. All right, so you see I have a battery here, and that is connected through the one layer of the switch, which is going to determine the direction of the train. If I turn the switch to the left, any one of the three positions, it'll provide power to this double pole, double throw relay through this resistor. And this relay is what determines the direction. So If I throw the switch to the left, like I said, any 3 positions to the left, it'll turn on this relay, and we'll turn on the relay, and you will have power to the traction in one direction. Now, if I turn it to the other direction, it'll still provide power. However, it's not going to turn on this relay, so it'll now turn off the relay, and it'll provide power in the opposite direction. And that's all determined by voltage coming from this pulse width modulation right here. See, the plus goes to one leg of the relay, and the negative goes to the other leg of the relay. And this is wired like a normal double pole, double throw switch you have in your in a normal layout. Okay, so this right here, the 2 diodes, just acts as an OR gate because it's one way or the other way. You're still going to have power going through this. The only difference is, will this relay turn on or off? All right, so that's how the direction comes into play. The other part of the potentiometer, the other part of the rotary switch is connected to a pulse width modulation circuit. Now, there is a potentiometer or rheostat, whatever you want to call it, was connected to this pulse width modulation. I cut that off and took the 3 leads and reconnected it to the top part of the switch. And as you know, it's just a variable resistor. Potentiometer is just a variable resistor. So I'm just setting fixed points. So I don't have the resistors drawn in here, but I believe I put a 20K, 40K, and a 20K to determine the speed. And depending on which direction I turn this in, you can see if I turn to the first spot, it's the same as the first spot. The other direction, second spot, same spot as the second. And the third position is tied to the other third position. So either direction, it's going to give you the same speed. Now remember, these 2 are tied together, so when I turn this is also going to turn. So this will determine the speed. And on the output, we will have anywhere from, I think it was 3.5 volts to 9 volts, because this entire circuit is powered by a 9.6 volt nickel metal hydride battery, very stable battery. I have a fuse right here, so just in case the rails would be shorted out, it would protect everything and the fuse would pop. I built in a charging point, so when this is in the center off position, I can connect my charging plug and it will charge through this battery.